Hello, I am Seema and welcome to part 4 of the chapter Alcohols, Phenols and Ethers. We have been doing the nomenclature of alcohols, phenols and ethers. In this video and the consecutive with the next video, I'm going to be solving your exercise and in-text questions based on the IUPAC nomenclature. I had not thought that I would be doing it in so much details, but I think it will be helpful for you. So these two videos are going to be more like a game. We know all the rules of the game. We just have to follow those steps and name these compounds. So let us start. This is Intext question 11.3. You have to name the following compounds according to the IUPAC rules, or you have to give the IUPAC name for these compounds. The first compound is CH3CH2, CH, CH2Cl, CH, CH2OH, CH, CH3 and CH3. Now, if you look, what is the first rule of IUPAC nomenclature? Is the longest chain rule. If I look at this, I feel that 1, 2, 3, 4, 5, 6. This appears to be, of course, it is the longest carbon chain. But there is another thing that we have to keep in mind when we are choosing the longest chain. The functional group should be in the main compound, in the parent chain. So the functional group here is alcohol, OH. Therefore, this carbon should definitely be a part of the main compound. So I'll take this carbon as the first carbon and then choose my longest chain. So this becomes carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. I have 5 carbons instead of 6. But now my parent hydrocarbon has 5 carbons. I could have chosen 1, 2, 3, 4 would be butane, or 1, 2, 3, 4 would also be butane. So the longest chain along with the functional group has 5 carbons. So this becomes my longest chain. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Now on the basis of this, what are your substituents? One substituent is here. This whole thing becomes a substituent, and CH2Cl is my second substituent. And OH is the alcoholic group. So now I have to see how will I give the locants to these substituents. And you remember, when you write the substituents which are written as prefixes, we always write them in the order, in their alphabetical order. But we assign the locants. We write the locants as they appear according to the lowest sum of locants rule, which means that I will try to count here where CH2OH is on the first carbon, then automatically my counting comes in this direction. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So we have branches on carbon 2 and carbon 3. Now what are the names of these branches? If you see in common nomenclature, we call it isopropyl. This is an isopropyl group. Isopropyl is a term that is adopted by IUPAC also. So you can use isopropyl. Sometimes the term iso is used in IUPAC nomenclature, but if you want to ignore that part and you just want to go by the strict rules of IUPAC nomenclature, you can write this, instead of writing this as isopropyl, you can write it as 1-methyl ethyl. Right? We say that ethyl is the alkyl group, and the methyl group here is attached to the first carbon, assuming that this first carbon is attached to the chain. So this carbon becomes the first carbon of ethyl group, carbon 1, carbon 2, so this is ethyl, and 1-methyl ethyl is the group. So M, 1-methyl ethyl. So M is the alphabet with which it is starting. And what is this? This is chloro-methyl group. A methyl group is CH3. One of the hydrogens of the methyl group has been substituted by chlorine, so it is chloromethyl. So C comes before M, so we write chloromethyl first. And what is the locant? Which carbon is chloromethyl attached to? It is attached to the third carbon. So we say 3-chloromethyl hyphen 2 hyphen. On the second carbon, what do you have? You could put it in a bracket, 1-methyl ethyl, right? You can write on the first carbon there's a methyl and it's an ethyl group, and what is this? It is pentane 1, 2, 3, 4, 5, yeah. pentane 1 all. Right? In place of 1 methyl ethyl, you could have written 2 isopropyl. By writing isopropyl, there was no need for you to add a second locant. That is, this 2 is the locant at which carbon of the main chain isn't attached, and the second locant is actually the carbon of the branch to which carbon of the branch is the methyl group attached. So in such cases where you may have a little complexity, IUPAC allows you to use isopropyl or the iso part. Even if I had used iso, I comes after C, so the naming would still be in this sequence. So the name of this compound is 3-chloromethyl 2,1-methyl ethyl pentane 1 all, or 3-chloromethyl 2-isopropyl. Instead of this entire bracketed space, you would write 2-isopropyl pentane 1 all is the name of the compound. Interesting. Let us come to the second part now, the second compound. This is CH3, CH, CH3, CH2, CH, OH, CH, CH2OH, and CH3. So the alcoholic group I see is here and it is here. So I will choose my chain in such a way that both the alcoholic groups are contained in it, and this is treated as a branch. Right? The same thing, I would prefer to keep the alcoholic group, that is the functional group, in the main chain. So this becomes carbon 1Y because it has the alcoholic group. So I'll treat this as carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So these are the 6 numbers how I will be writing it. So what are the substituents then? This methyl group is a substituent. The OH is a functional group, but it is a branch, and a methyl group here. And there is one OH here on the first carbon. So when we are going to write the name, we know that it is 1, 2, 3, 4, 5, 6. It is hexane 1,3-diol. This compound is hexane 1,3-diol, but it has a methyl group on the second carbon and a methyl group on the 5th carbon. So we'll write 2,5-dimethyl. There are 2 methyl groups, so we'll write the locants for both the methyl groups. There is no need of choosing the alphabetical order because both are methyl groups. So 2,5-dimethyl and hexane 1,3-diol, right? Hexane 1,3-diol. There are commas when you have multiple locants, but on the 2 sides you put hyphens. When the name is starting, there is no need of a hyphen because a hyphen is for continuation. So when the locants come in the middle somewhere, you put 2 hyphens, and if there are multiple locants, you put commas between them. Here we start with 2, the first locant, 2,5-dimethyl hexane, and there should be no space between these. It should be one single word, right? Come to the third compound now. It has 6 corners, so it is cyclohexane. It is saturated, no double bond, so it is cyclohexane is our compound. And it has bromine and alcoholic group. Do you see? The 2 branches it has are bromine and the alcoholic group. Bromine is always treated as a substituent. All halogens are always written as prefixes and they are substituents. So the functional group, which is written as a suffix, is all, that is alcohol. So OH is more important than Br, therefore this carbon becomes the first carbon. And then we start counting in such a direction that Br gets the smaller locant. If I count in this direction, this is carbon 1, carbon 2, carbon 3, 4, 5, 6. But if I count from this direction, carbon 1 has OH, 2, 3, 4, 5. Br is the fifth carbon. I will not count in this direction. I will count in this direction so that my locants are lower. That is 1 and 3 are smaller numbers than 1 and 2, 3, 4, 5. 1 and 5. So now comes the naming. In the naming, we'll first write the substituent. So the substituent bromine is on the third carbon. So we'll say 3-bromo. It's cyclohexane 1-ol. The E is removed. So cyclohexane 1-ol. 3-bromo cyclohexane 1-ol. Fourth compound. Let us come to this. CH2 double bond CH. So it is an alkene. It has a double bond. CH2CH, CHOH, CH2, CH2, CH3. So it is an alkene. And what is the number of carbons that it has? 1, 2, 3, 4, 5, 6. 6 carbons. So it is hexene. And if it is hexene, I will try to, if I count from this direction, the ene gets the lower number here. And ol also comes on the third carbon. But if I count from this direction, 1, 2, 3, 4, fourth is ol, and fifth is ene. So according to lowest sum of locants rule, I will count in this direction. So this is carbon 1, carbon 2, 3, 4, 5 and 6. So it is hexene. And on the third, hexenol. So on the third carbon is the ol. So it is hexene, hex 1 N 3 ol. Hex 1 N 3 ol. Now the next compound, CH3C, CH3, double bond C, Br, CH2, OH. A lot of substituents and functional groups. The functional group is OH. Br is a substituent and CH3 is a methyl group. There is unsaturation also. This is the longest chain. It is butene, right? It is butanol, N-ol, where it is an ene and it has the alcoholic group too. And bromo and methyl will become the substituents. So alphabetically, bromine will be is smaller in alphabet. B comes first and M comes later. So we'll give the numbers. We'll start counting in this direction because the ol is here. 1, 2, 3. If I had counted from this direction, my locants would have been 2, 3 and 4. And here it is 1, 2, 3. So I would choose the counting from this direction. So this is 2-bromo, right? 3-methyl, 2-bromo, 3-methyl, but 2N, 1-ol. Am I clear? So it is 2-bromo, 3-methyl, but 2N, 1-ol. 2-bromo, 3-methyl, but 2N, 1-ol would be the name of this compound. So this was in-text question 11.3. Give me a moment to write the exercise question now. Alright, let us now solve question 11.1 of your NCERT textbook exercise. The question has 12 compounds that have to be named. I have put 6 compounds on the board and I'll be writing 6 after this. Let us first name these 6 compounds. We have to write the IUPAC names of all these compounds. So look here. What do you have? The longest chain first. The longest chain would be 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. In all the cases, or if you start like this 1, 2, 3, 4, 5, you get 5 carbons. So I will choose the straight chain. It is easiest to have this. So my chain is 1, 2, 3, 4, 5. Now which side will I start counting will depend on the lowest sum of locants rule. What are the substituents and the functional groups that I have? This is a functional group I have. This is 1, this is 1, the functional group is OH and these are the substituents. So, or the branches. So, I have 4 branches that I have to name and give locants to. 4 things that need locants. So, what is it? 1, 2, 3, 4, 5. It is pentanol. But it is pentan, the ol is not on the first carbon. If I count from this direction, my locants will be 2, 2, 3, 4. But if I count from this direction, it will be 2, 3, 4, 4. Obviously, 2, 2, 3, 4 is smaller. So, I'll count from this direction. This becomes carbon 1, 2, 3, 4 and 5. Now, there are 3 methyl groups. So, if there are 3 methyl groups, all you have to do is give the locants. So, 2, the first 2 are 2, 2. This methyl is on the 4th carbon. 4, trimethyl. We always start the name with a capital letter. When you write your name, you always start with a capital letter. Remember, in IUPAC nomenclature also, you are naming a compound, you're giving the name. So, the first letter is always a capital letter, but the rest are always small letters. So, 2 to 4, trimethyl, and the rest has to be in continuation. There should be no gaps. So, unless you have to write the locants or what, but for that, there are no gaps. Again, you give a hyphen, you write the number, give a hyphen, then write the name, go on with the name. So, 2 to 4, trimethyl, and this is pentan, and the ol is on the 3rd carbon. So, pentan 3 ol will be the name of this compound. Clear? Next compound. My back is killing me. Okay. CH3, CH, CH2, CH, CH, CH2, CH3. So on the branches you have OH, you have C2H5 and you have OH. Again, longest chain 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right? Because this can be written as CH2, CH3. But this side is also CH2, CH3. This is also C2H5. So why should we try to make it more complicated by choosing a zigzag or twisted chain? I like to go with this one and I'll treat this as the substituent, this as the functional group and this as the second functional group. These chisel pens, I don't like them, I like bullet tips. Anyway, so these are my branches and this is 1, 2, 3, 4, 5, 6, 7. So it is hexane and it is an ol and it is a hexane diol. There are 2 ols. And then this is the substituent. So if I count from this direction, 1, 2, 3, 4, 5, 6. So my locants would be 3, 4, 6. And if I count from this direction, my locants will be 2, 4, 1, 2, 2, 3, 4, 5, 2, 4, 5, which is smaller, obviously this one. So my counting will be from this direction. So this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. And let us now name it. It is ethyl group is present. So we'll write the substituent or the prefix. Ethyl is written as the alkyl group is written as the prefix. So I'll write the alkyl group first. It is 5-ethyl. 5-ethyl hex and 2, 5, no, not 5. What is the other ol on? It is on the 4th carbon. 2, 4 diol will be the name of this compound. 5-ethyl heptane. It's not hex, it's not 6 carbons, it is, sorry, missed this. Heptane. Heptane 2,4-diol, right? Next compound, CH3, CH, CH, CH3, 2 ols. So it is a diol and it is a butane diol. It's a straight chain, 4 carbons. So it is butane and so this naming is easy. Butane. If I count from this direction, it is 2, 3. If I count from this direction also, the locants are 2, 3. So it doesn't make a difference which direction you count in. Butane 2, 3 diol would be the name of the compound. Compound 4, OH, CH2. CH, OH, CH2, OH. This is nothing but glycerol. Only it has been written in a manner to confuse you. You know how is it written otherwise? CH2, CH, CH2, OH, 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 which we say is glycerol. Here the OHs have been written in a way that is, intentionally they try to confuse you, while the question, the compound is actually very simple. It is glycerol. So the longest chain, carbon chain, 1, 2, 3, it has 3 carbons, so it is propan, it is all, it is a triol. So we'll write propan, oh sorry, it should have been a capital letter, PROPAN hyphen 1, 2, 3 triol, or glycerol is the common name. Then comes the next compound. This is benzene ring and it has OH, so it is a phenol. This is a phenol, so we know this part is written as phenol, and the methyl group is a substituent on the phenol, and I will obviously count if when we say phenol, it means the carbon which has OH is carbon 1. So I'll count in this direction because this will get carbon 2. If I count in this direction, methyl will get 2, 3, 4, 5, 6. Why would I do that? Lowest sum of locants, 2. This is 2 methyl. Now what have I done wrong here? The P I wrote capital. Since it is ending, it is not the beginning of the name, the P will have to be small. You have to keep this in mind, that you do not end up writing more capitals than required. Only the beginning should be a capital letter. So this is 2-methyl phenol. So what would this be? This is also phenol, and here 1 is phenol, 2, 3, 4. 1, 2, 3, 4. In both the directions you get the locant 4. So it is 4-methyl phenol. Right? So this was the name of the first 6 compounds. Now give me a moment to write down the next 6. Now moving on with the question. This is part 6. The compound you see here, part 7. The compound you see here is phenol. It has got OH attached to the benzene ring. And obviously the OH, the carbon which has OH is carbon 1. So this is carbon 1. Now I have to choose the locants for the methyl groups. If I count from this direction, the locants would be 1 is OH. It will be 2 and 5. 2 and 5. But if I count in this direction, 1, 2, 3, this will be 3 and 6. The lower locants are 2 and 5. Therefore, I will count in this direction. So I'll write the name. It will be 2, 5, second carbon, 3, 4, 5, 2, 5, dimethyl phenol. Phenol is understood that the OH is on the first carbon, right? So that is the name of this compound. Come to the next question, part 8. CH3OH CH3. Again, it's a phenol. And this is carbon 1. If this is carbon 1, I can count in this direction. 2. So my locants for the methyl groups will be 2, 3, 4, 5, 6. 2, 6. If I count in this direction also, 2, 3, 4, 5, 6. 2 and 6. In both the directions, my locants are 2 and 6. So it makes no difference which direction I count in. So it doesn't matter. I'll just write it is 2, 6 dimethyl phenol. Right? Assuming that phenol, the OH is getting the first carbon. So let us now do the 9th question. This is CH3O, CH2, CH, CH3, CH3. Do you see? This is an ether. There's an oxygen in between. And on one side you have CH3, on the other side you have CH2, CH, CH3 with a branch. This is the larger hydrocarbon. So we assume that there are 2 alkyl groups. Which is the larger group? Here. So 1, 2, 3, it is propane. And this is a methyl group attached to the propane. And this becomes the substituent. It is treated as a substituent. So now when we name, how will you number it? You will call this the first carbon because this has the functional group attached to it. This is the second carbon, this is the third carbon. So there is a methyl group attached on the second carbon, and on the first carbon you have methoxy. Both start with M. So I'll say 1-methoxy, which is the functional group. 1-methoxy, alphabetical order, and methyl. O comes before Y. just assuming this, and 1-methoxy 2-methyl 1-methoxy 2-methyl propane is the name of the compound. Next compound, C6H5O C2H5. Now this has only 2 carbons, this has 6 carbons, this is the benzene ring. Alright, so ethoxy, this becomes, this, since this has lower number of carbon atoms, this is the parent, hexane, and this is the ethoxy, is the substituent. So we'll write ethoxy 1, on the first carbon we'll assume it is 1-ethoxy it is benzene, ethoxy benzene, because it is C6H6 is the benzyl group. So it is 1-ethoxy benzene. Yeah. This compound now, this has benzene here and it has C7H15 normal. Normal means a straight chain. So C7H15 is heptane or the heptyl group, and this is the benzyl or the phenyl, sorry. So this, we'll write this as, since this has 7 carbons, this has only 6, this becomes the parent and this becomes the substituent. So I write that it is 1, since it's normal, I'll call it 1-phenoxy heptane. 1-phenoxy heptane. Let me just make sure 1-phenoxy heptane is the right name. Number 12. CH3, CH2O, CH, CH2, CH3, CH3. Again, you have only 2 carbons on this side and you have 3 carbons on this side. So actually 4. So this is, you could treat this as butane, and yeah, this is butane, this becomes the parent hydrocarbon, and the ethoxy is attached to the second carbon of butane. So we say 2-ethoxy butane. 2-ethoxy butane will be the name of this compound. This is the first carbon, this is the second carbon, third, fourth, right? So that is not a branch, it is a chain of 4 carbon atoms. And on the second carbon is the attachment of the ethoxy or the functional group or the substituent as we call it here. So this was question 11.1 of your textbook exercise. In the next video, I'll be doing question 11.2 and probably 11.3. And with that, we will finish nomenclature. So I'll wind up the video here. If you wish to watch other videos of this chapter, please click the link that appears on top. If you found this video helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.